Welcome back. We're going to take a look at part two. But before we do that, I'd like to go back up and look at the number line again when you were classifying numbers. I had made a note to myself and I just want to make sure we talk about it. Um, when you're trying to decide with your negatives if it belongs in the -1 or the -1/2, something you can think about is the halfway point between 0 and -1/2. And the halfway point between 0 and -1/2 is -1/4. So typically, if the value is more than -1/4, we place the number in the -1/2 column. Okay, so I'm just going to pause a minute because I know you're still writing, but halfway between the 0 and the -1/2 is -1/4. So if the value is more than -1/4, we place the number in the -1/2 column. And it looks like our -1/2 decided to disappear up there, so we're going to put it back in. Okay, so looking at number 6, you know lots of different ways that you can compare fractions. So without drawing them. So without drawing them, different methods you can use. You can convert to decimals. You can find the LCD and make equivalent fractions. You can use cross products, which you learned last year. Whoops. You can convert to percents. Or the new thing we addressed today was comparing to 1/2. And so, you're going to be given a lot of different tools for your mathematical tool belt this year. And it's going to kind of be up to you, like which method you want to do when. Sometimes it'll be easier to group when it's a long string of numbers. Sometimes all the numbers are going to be really easy for you because they're things you already know how to convert into percents. And so you're going to have to look at each situation individually to figure out which strategy to use when. Okay, so we're going to take a look at number 7. So it says that 4 people found the distance in kilometers across Nowhere Canyon using different methods. Their results are given in the table, and then they ask you to plot and label them on the number line below. So looking at the halfways, we know that this is going to be 5.1, 5.3, 5.5. If it helps you, you can go ahead and write it in. 5.25 is slightly greater than 5 2/10. So we are going to move over to the right-hand side and we're going to label this with Joanna. I'm going to go ahead and write it sideways just so that I have enough room. So looking at 23/4, lots of different ways to look at that. But if you convert this into a decimal, we're looking at 5 3/4. So if 5.7 is here, we know that 5 3/4 is going to go halfway in between. And so that's going to be Lori's number. So please, 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 when you're making number lines, actually put the point and fill it in on the number line, like not floating above, but actually on it. When we're looking at 5.5 repeating versus 5.5, these two are really important. So I'm going to put little stars by them and change the color. So looking at Jet, we have 5.5. So we're going to come in, we're going to put this point here, and we're going to write Jet's name. The question is, where does the 5.5 repeating go? And so the 5.5 repeating is bigger than Jets. So we're going to go ahead and put a point to the right. And then we're going to go ahead and put Rachel. And a way you can compare that, if you want to, is by taking the numbers and expanding them. And we're going to take a look at that on number 8. So it says that Joe says that 12.6 repeating is less than 12.63. Do you agree? Explain why or why not. I would encourage you at this point to hit pause so that you can think about it on your own. Okay, so now that we've had a little bit of time to think about it, Joe is incorrect. And the reason Joe is incorrect is because 12.6 repeating in expanded form is 12.66, and then it's going to keep going on with the sixes forever. When comparing the hundredths place, because that is going to be where the numbers break apart. So when comparing our hundredths place, and the spelling on hundredths is important to make sure that we have the THS at the end, we know that 6 is larger than 3. Okay, so 4 and 3/10 versus 4 and 2/7. Which one do we think is bigger? Okay, we think that this one is bigger. Looking at negative 4 and 3/10 versus negative 4 and 2/7, thinking about what we were doing in part 1, we know that that's going to be the opposite. So we are going to have a less than sign. And I'm going to go ahead and give you time to put the numbers in there. But between the 4 and the 5, we know that those are all tenths. So 4 and 3/10 is going to be here. And we know that 4 and 2/7 is going to be slightly smaller. These are not my favorite number lines. Looking at the negative 4 and 3/10, we know that we have it here. So we're going to have negative 4 and 3/10. And then looking at the negative 4 and 2/7, it's going to be less negative. I'm going to make a little line here so that you can see where it goes. We have negative 4 and 2/7. Okay, so we're almost done. So it says plot and label each fraction on a number line. Fill in the blank with a less than, greater than, or equal to. How do you know your answer is correct? Justify your answer. So looking at these two, there are a lot of different ways you can talk about it. I would probably put this on a number line, looking at where the negative 2.15 is versus the negative 2.13, but you don't have to. This is going to be a less than sign, and you could use as a justification that negative 2.15 is further left on the number line. So we're looking at a negative 2.13 being roughly there, and we're looking at a negative 2.15 being right next to it. Okay. Looking at this one, 0.15 and 3/20, that is equal. And you can just say, for your justification, 3/20 is 0.15 in decimal form. So just because it says justify does not mean that the explanation has to be humongous. So we're looking at 0.15, and this is also 3/20. Okay, if you had been in class, like live, this is where you would be going into breakout rooms to work on the word problems. Since we don't have that as an opportunity, I'm going to walk you through them. If you feel comfortable, I would say try and do these on your own and then come back to take a look. The most important thing is making sure that your work is nice and tidy. So it says that it takes Alan 3/5 of an hour to complete his math homework. So if we're dealing with math homework, an hour has 60 minutes. So you are looking at 36 minutes. Then it says it takes 5/6 of an hour to complete his reading homework. So we have 5/6 times 60, which will give us 50 minutes. So then it says 2/3 of an hour doing the science homework. So if we look at that, we're looking at 40 minutes. People always want to know why I do this in minutes first. I do think it's easier to then convert all these back into parts of an hour. Because if you look at how many hours total he spent on his homework, you know that 40 plus 50 plus 36 is 126. And that is the same thing as 2 hours and 1/10. And because it's asking you in the problem for how many hours, that means we do not want minutes in the end answer. So Alan spent 2 1/10 hours doing homework. Okay, looking at number 14, it says that Bob worked 8 hours. Janet said she worked a third of the day, so a third of 24 is going to give us 8. Then we have 30% of 24, and that's going to give us 7.2. Again, my suggestion is to try and do the word problems first on your own and then come back and check your answers. So we know that Bob and Janet work the same amount, but Liz worked less time at 30% of the day. So it says that Lisa is a radio reporter and is allowed 90 seconds to relate a story. What fraction of a 30-minute broadcast is that? So we need to make sure that the units are all the same. So we have 30 times 60. That will give us 90 over 1800. Thinking about our reducing rules, we could take the zeros out, and then 9 goes into 18 twice, so you're looking at 1/20th. So Lisa's report is 1/20th of the entire broadcast. So really it's about reading for detail. And if you like using highlighters or colored pencils to help you with that, I would definitely encourage that. It's part of why we gave you printed modules. So the results of a survey of 100 families show that 55 families only use the YMCA swimming pool. And then it said 20 families only use the tennis courts. And then we have 15 families that used both. So if we subtract that to get 100 minus 55 minus 15, that's going to give us 10. So we have 10 left over. So 10 out of the 100 reduces down to 1/10. So 1/10 of the families use the pool or do not use the pool or the courts. And that's a wrap. I'll see you guys tomorrow.